Hello everyone. Today we are going to discuss on OpenGL Pixel Array Functions, which comes under subject computer graphics and image processing. So let's begin. So here is the agenda of what we are going to discuss in this presentation. So firstly we are going to discuss about the overview of the OpenGL, what is OpenGL, introduction about pixel array functions, or some key functions and their users like glDrawPixel, glReadPixel, glCopyPixel, glPixel stores. Next, we are discussing about pixel transfer operations. Next, applications of pixel array functions and performance of considerations. Lastly, we will conclude this presentation. So let's begin. Initially, we'll discuss what is OpenGL. OpenGL it is a cross-platform open standard for rendering 2D and 3D graphics. Its purpose is it provides a powerful setup of functions for creating high-quality graphical applications. And the core idea behind using OpenGL is it acts as an intermediary between the CPU and the GPU, enabling efficient rendering of graphics. Now let's see what is OpenGL Pixel Array Functions. OpenGL Pixel Array Functions allow for the manipulation of pixel data directly. This is useful for tasks such as image processing, texture manipulation, and frame buffer operations. So let's see some of the key functions and their usages. First is glDrawPixel function. The purpose of using glDrawPixel function is it is used to draw block of pixels to the frame buffer. This is the syntax how we can use the glDrawPixel function. Here gl size I, here I indicates the integer value. Now let's see the parameters used in this syntax. So width and height. It it provides the dimensions of the pixel rectangle. We know always pixel is in the form of a rectangle, so it provides the dimensions of the pixel. Next, format of the pixel data. For example, it gives a color value in the form of RGB, that is red, green, blue, or with angle, red, green, blue, and angle. Next, type. It provides the data type of the pixel data. Example, GL unsigned byte or GL float. Pixels. Here the pixels indicates the pointer to the pixel data. So here is an example of using glDrawPixels. Here the size of width and height is 100 and 100, and parameter format is RGB value. Next, data type is unsigned byte and pixel data. Now let's see the next function, that is glReadPixels. The purpose of using this function is it is used to read a block of pixels from the frame buffer, and this is the syntax of using the glReadPixel function. Let's see the parameters used in this glReadPixels function. X and Y parameter. Here X and Y indicates the coordinates of the lower left corner of the rectangle, and width and height is the dimension of the pixel rectangle. Format it is the like background color, like that. It is given as GL RGB value. Red, green, blue RGB indicates. Here RGB A indicates the red, green, blue angle as we discussed in the glDrawPixels. Type is the data type of the pixel, and pixels it is the pointer to the buffer where the pixel data will be stored. So this is the example uh, in which in this way we can use the glReadPixels. So 0, 0 it indicates the lower left corner of the rectangle, 0, 0. Next 100, 100 it is the size of the, that is width and height of the rectangle. Next, that is pixel rectangle. GL RGB, it is the format. GL's unsigned byte, it is the data type of. And next, pixels buffer, it is the pixel data pointer to the buffer where the pixel data will be stored. Next is glCopyPixels function. The purpose of using glCopyPixel function is it is used to copy the pixels from one part of the frame buffer to another. This is the syntax how we can use the glCopy function. So let's see the parameters x and y as we discussed in the glReadPixels. It is the coordinates of the lower left corner of the source rectangle, and width and height is the dimension of the rectangle to copy. Next to type of the copy operation. For example, GL color or GL depth. This is the use of how we can use the GL copy pixel function. GL copy 10, 10, 50, 50 GL color. So here 10, 10 is a coordinate value point from where the lower left corner of the source rectangle, and 50, 50 is the size of the rectangle. GL color is the type. So now let's see a GL pixel store function. So the usage of this GL pixel store function is it is used to set the pixel storage modes. And this is the syntax how we can use the GL pixel store function. So let's see the parameters used in this function. So firstly, pname. It is the storage parameter to be set. For example, GL unpack alignment or GL pack alignment. Parameter, it is the value of the storage parameter. So this is the example how we can use the GL pixel storage. GL pixel store I indicates the integer values in the parameter. Next, GL unpack alignment, it is the p name parameter, and 4, it is the value of the storage parameter. Now let's see the pixel transfer operations. So common operations used for pixel transfer is scaling, biasing, and color mapping. And the functions involved in these are GL pixel transfer. F indicates the floating value. GL pixel map FV. Here FV indicates the F is the floating value and V is the vector. So these two functions are involved in these operations. So now let's see the applications of using the pixel array functions. It is used in image processing, applying filters, transforming images like that. Next is the texture manipulation, updating the texture dynamically, so font size like that. Frame buffer operations, capturing screen content, creating effects. Next to scientific visualization, displaying data from simulations or computations. Now let's see the performance considerations of using that OpenGL Pixel Array functions. So initially, that is bandwidth. Pixel operations can be bandwidth intensive. It uses the appropriate data types and formats to optimize performance. Next, hardware acceleration. It leverages the GPU capabilities for efficient pixel manipulations. So at last we conclude that the OpenGL pixel array functions provide powerful tools for manipulating pixel data. Understanding these functions is crucial for tasks ranging from simple image manipulations to complex rendering techniques. Proper usage and optimization can significantly enhance the performance and quality of graphical applications. Thank you.